Hello, algebra. Check out this do now. It's like a treasure map, pirate treasure. Find out what number x would be. Where would x be on that number line? You don't have to use the number line, but I think it would be very helpful. Distance between x and 6 on the number line, the spot 6, it's 3 spaces. All right, hit pause so you get that figured out. Nice work. So we're going to use my little graph walker to help us get this sorted out. So if I put my little graph walker at 6, I can go either 3 spaces to the left and end up at 3, or 3 spaces to the right and end up at 9. So 2 possible solutions, either x is 3 or x is 9. Nice. All right. Well, today we're going to look at solving absolute value equations with our goal. We'll be able to solve absolute value equations. So we've been studying absolute value for just a little bit here. We started off with evaluating, which is where we have all the numbers and we do the order of operations in the correct order. Solving is just the reverse process of that. So kind of like in the do now, we had to figure out what x was. That's what solving is going to look like. So we've got some steps we'll need to follow in the correct order to do this process. First, we want to isolate the absolute value, that's those vertical lines in the equation. If there are any numbers or terms that are outside of those lines, either to the left or the right of them, outside the lines, but on the same side of the equal sign, same side of the equation where the absolute value is, we have to cancel those outside terms first. That's step one. Just the absolute value, we need to have that isolated. Second step, we're going to split the problem into an OR problem, just like the OR that we saw when we were learning about compound inequalities previously. So we get to make a trade. We take those lines out of the original equation, and in its place, we get 2 equations back. We're going to get one that looks exactly like the original equation, except without the lines. And we'll get a second one that has the opposite sign on the other side of the equal sign. The other side of the equation will be negative. Okay, we'll see what that looks like here in just a second. Step 3, solve both of those 2 equations, the green one and the magenta one. Solve them both separately. And then step 4, we'll end up with 2 solutions, one from the green equation, one from the magenta equation. Connect those 2 solutions with the word OR. OR does not mean that you, as the algebra student, get to make a choice about whether it's this one or that one. It means that there are 2 solutions, and we use the word OR to combine those into one like answer box. Lastly, we need to check for extraneous solutions. Extraneous is basically a complicated math word that refers to like fake answers. We will not see any of those to start with here for today, but that will be coming in the future. And so I want to set the precedence for checking for extraneous solutions. All right, let's see some examples. So first up, solve this equation, absolute value of x minus 5 equals 7. All right, well, the absolute value right there inside the lines, that is the only thing on the left side of the equation. So step 1 is to isolate the absolute value, and we don't actually have to do anything to accomplish that this time. Absolute value has already been isolated. So step 2, we are going to break this apart into 2 problems, or make a trade. So instead of those absolute value lines, I'm going to have x minus 5 equals 7. So there's one equation, and then the other equation is going to say x minus 5. Still no absolute value lines, right? We traded those in, and in their place, we get 2 equations. This blue one is going to be equal to negative 7. Okay, so I'm going to solve those 2 equations are connected with the word OR. And now let's solve them one at a time. So I'm going to do the green one first. We're going to add 5. X equals 12. Now let's do the blue one. Again, we'll have the same steps here, but we're going to get totally different numbers. So I'm going to add 5 to both sides. X equals negative 2. All right, so there are my 2 solutions. I get a green solution, a blue solution. We're going to continue connecting those with the word OR. All right. So one thing I just want to point out, a lot of times people think they found like a math hack. They're like, oh, just do the green one and solve that. The x minus 5 equals 7. And then whatever answer I get, I'll just make that a positive and a negative, and then it'll be done. They'll save the work, which is great thinking. It would be fabulous if that worked, but it doesn't work. So you can see when we actually do the work here, we got different numbers. We got positive 12, we got negative 2. So you can't just do one and like double it up to get your other answer because it doesn't work that way. Okay, so my directions said to graph. That's not actually part of the assignment today, but I think it is very important for us to understand what is going on here and why we solve the equations in this way. So I want to look at the graph. Let's put these two dots on here. So I got positive 12. There's one solution. And I got negative 2. There's the other solution. All right. Now, I guess by itself, the graph is not really very helpful, but let's jump back here to the original equation we were solving, and let's see if we can get a little bit more clarity here. So the original equation, absolute value of x minus 5 equals 7. Let's translate that. So absolute value, the definition I first gave you for absolute value is it refers to the distance between 2 points on a number line. Okay, so we have 2 points on a number line. The solutions, negative 2 and 12. And that's not actually the 2 points that we were talking about when we were talking about distance between the 2 points. So in this original equation, let's break this down by color and look at what each of those parts means if we were to translate the number sentence into a word sentence. So absolute value in purple means distance, right? The yellow subtraction, we could translate that to mean between. And then inside the lines, those are the 2 points we're finding the distance between. It's x and 5 that are in there. So we're finding the distance between x and 5 on the number line. That distance is 7 spaces. So if I grab my graph walker here, bring the graph walker up and position him right at 5 on the number line, if my graph walker starts at 5 on the number line and goes 7 spaces to the left, we'll arrive at negative 2. That's one solution. And on the other hand, if my graph walker goes 7 spaces to the right, we're going to end up at 12. And that is the other solution. So there's like a middle point, and our two answers are symmetrical. They've gone 7 spaces in each direction, but so we don't end up at like positive 12 and negative 12, which is like what a lot of times people be like, oh, that'll make it easy. I'll just do that. But since we did not start with the graph walker positioned in the middle of the number line, like at 0, you're not going to get the same number, but positive and negative versions of it. Right? We end up with different numbers for our two solutions. Okay, let's see another example. Let's skip that one. Let's do another example here. Absolute value of 3x plus 5 equals 1. All right. Well, again, the absolute value needs to be isolated first. And it is. There are no numbers or terms outside of the absolute value on the left side of the equation. So we can go ahead with our trade. Let's trade in those absolute value lines to get two different equations. We'll get 3x plus 5 equal to positive 1. And then our other equation, 3x plus 5 equals negative 1. Okay, don't forget the word or. And now let's solve. We'll do the green one first. Subtract 5 from both sides. So 3x equals negative 4. Now I'm going to divide by 3. And that brings me x equals. I'm just going to leave this as a fraction for two reasons. One, it's actually easier than like dividing or trying to get a decimal version. And secondly, usually in OneMap, we're going to want our answers written in fraction form anyway. So negative 4/3. Okay, let's look at that blue version now. So the steps to solve this are going to be the same, but I'm just going to get totally different numbers to deal with. So subtract 5, that comes first. 3x equals negative 6. And then divide by 3. And this time we get x equals -2. All right. Connect those two solutions with the word or. And we have finished.